DU MME 2024 question number 5. Solve the consumer demand problem. Maximize x power a plus y power a subject to px plus qy equals to m, where a belongs to the open interval 0, 1 and x is positive, y is positive. Also check the second order sufficient conditions. Okay. So, okay. So what are we supposed to do? We are supposed to maximize fxy is equal to x power a plus y power a belonging to the open interval 0, 1, subject to gxy is equal to m, where gxy is equal to px plus qy. Okay. So let us set the Lagrange function. The Lagrange function is set up as fxy minus lambda times gxy minus m, where lambda is positive. Okay. So let us set up our function. So L xy lambda is x power a plus y power a minus lambda px plus qy minus m. Okay. So what are the necessary conditions for maxima and minima? The first, partial derivative with respect to x and partial derivative y with L with respect to y should be 0. So what is the partial derivative with respect to x? A x a minus 1 minus lambda p should be equal to 0. So lambda p is a x a minus 1. Partial derivative with respect to y is a y a minus 1 minus lambda q equals to 0. So lambda q is equal to a y a minus 1. Divide them. P upon q will be equal to x power a minus 1 upon y power a minus 1. So P upon q 1 upon a minus 1 is equal to x upon y. So y comes out to be x q upon p power 1 upon a minus 1. Okay. So let us try to find out our x now. So we basically need a candidate for maxima or minima for optimization. Okay. So we have px plus qy equals to m. This is our equality constraint which is given to us. So px plus q x q upon p 1 upon a minus 1 equals to m. So x p plus q q p. Okay. So your x will be m upon p plus q by p. This is your x and your y. So this is your x star, the candidate for optimum value, and y star will be this. So y star will be x. So this is m q upon p whole power a minus 1 divided by p plus q by p whole power 1 upon a minus 1. So we have got our candidate for optimum value. We don't know whether this provides us with a maxima or a minima. So as per the given question, we will go for the second order conditions. So what are the second order condition? Let us consider the determinant dxy, which is 0, g1 prime, g2 prime, g1 prime, g2 prime, f11 prime minus lambda g11 prime, f12 prime minus lambda g12 prime, f21 prime minus lambda g21 prime, f22 prime minus lambda g22 prime. Okay. If this determinant at x star, y star is positive, we will have a maximum. This is the sufficient condition. So what is my fxy? My fxy is x power a plus y power a. What is my gxy? My gxy is px plus qy. So one means differentiating with respect to x, two means differentiating with respect to y. So f1 prime will be a x a minus 1. f11 prime again differentiate with respect to x. Okay. g1 prime will be p and g11 prime will be 0. g2 prime will be q differentiating with respect to y, and again y again it will be 0. Okay. g12 prime, so differentiate the partial derivative of x with respect to y, 0. g21 prime, differentiate the partial derivative of y with respect to x, 0. f12 prime, differentiate this partial derivative with respect to y, 0. Okay. And now f2 prime was a y a minus 1 with respect to y now. And f22 prime will be a minus 1 y a minus 2. And f21 prime will again be 0. So let's try to make this determinant. So this determinant D at x star y star should come out to be 0. Okay. And g1 prime, which is p, g2 prime q, p, q. So f11, which is a minus 1, x power a minus 2. And this is then 1, 2 and g2 both are 0. And g11 is 0. This is 2, 1 and 2, 1 both are 0. Okay. So expand along the first row. So you'll get 0 minus p, okay, into p a minus 1 by a minus 2 plus q into minus q a minus 1 x bar a minus 2. So you will be getting p square a 1 minus a y a minus 2 plus q square a 1 minus a x bar a minus 2. Okay. So now let's take a into a minus 1 outside. It is p square y a minus 2 plus q square x a minus 2. So a is positive, a minus 1 is positive because a is between 0 and 1. P square is positive, q square is positive. And what were my, now these y and x have to be replaced by y star and x star, which we found from our first equation. So this is my x star and this is my y star, which is coming out to be. So these things will also be positive. Okay. And therefore my dx star y star is coming out to be positive. And therefore we have a maxima at the indicated x star and y star. All right. This is how we solve this problem using the second order sufficiency conditions.